Let's have a look at rotational symmetry. Now, the common question is to ask, what order of rotational symmetry does a shape have? So this is a badly drawn equilateral triangle, and an equilateral triangle has a rotational symmetry order 3, because we only need to rotate it so that this point's at the top, etc., etc. Oh dear. Anyway, you can do that 3 times. This is a 5-pointed starry thing, and a star thing with 5 identical spikes has a rotational symmetry order 5. I won't demonstrate that, but I'm sure you think it's right. And this peculiar shape here, this shape has 6 sides, but the inside triangles limit the rotational symmetry to 3. Let's just see if that works. We've got 3 lines of symmetry, but in order to get it right, this one has got to come all the way around so that this triangle is pointing up. Let's see if that works. 1, 2, 3. Very nice. But is it all about symmetry? This is what I ask myself. Here's a square, and it's got 2 lines of symmetry. In this case, a square has rotational symmetry order 4, because we only need to rotate it 90 degrees to get it into the right place. But an oblong, that has a line of symmetry here, and it has a rectangle has rotational symmetry order 2, because if you rotate it 90 degrees, we're doing the square. There's the square 90 degrees, and there's the oblong or rectangle. It doesn't look the same. So it's not just lines of symmetry, it's thinking about when does it become the same shape again as you rotate it. If it's every 90 degrees, you've got 4. If it's every 180 degrees, with this one, then it's only 2. Here's a hard question. Add a shaded square so that the shape has rotational symmetry of order 2. So let's rotate it around there and see where that goes to. That's 180 degrees. So that and that are sort of, if you like, paired. That's where this one goes. And I gave some thought to how we can calculate that, and I came up with this interesting discovery, by me anyway. If you are looking for symmetry order 2, reflect it in this line, the blue line, and then reflect it in the red line, and it'll end up there. This one, reflected in the blue line, goes to there. Where have we got 2 spaces and then the square, 2 spaces and then the square, and then reflected in the red line, where we've got a space, and we've got a space, and we've got the square. So that's where it goes. Of course, we can't leave this here, so we're going to we don't fill it in, we just mark it or use your pencil to point to it and then move to the next reflection. But that's how you find where that goes to when it's rotated 180 degrees. So let's have a look at your question. Here's the question asked in your paper, nasty little thing, and I've drawn it in here. And let's do each one in turn. We start with this one. I'm going to reflect it in the red line. So we come down here, all the way down here, 3 squares and then the blob, 3 squares and then the blob, and then I'm going to go across here. It's reflected in the blue line. So there's 2 spaces and then 2 blobs. 2 spaces and 2 blobs. Right. Blobs and spaces. This one reflected in the red, it's an easy one that comes to here, and reflected in the blue, so there's 3 spaces, 3 spaces. It's going to be there. And this block of 4, I'll just do in a oneer. I'll do it in the blue line first, so it's here, and then I'll flip it in the red line, and it comes down there. Does this work? It's very complicated, isn't it? So let's see, we've tidied it up. We're going to rotate through 180 degrees. It looks okay. Corner 2, 1 there, 4 pack there, and rotate it 2 there, 1 there, and that. That looks good to me. Anyway, I hope that helps. Oh, blimey, and another one. Add shaded squares so that this shape has rotational symmetry order 4. This is more complicated. We know that goes down there, and we know that gives us order 2, but that's not enough, because if we just do that 90 degrees, it's not going to work. So what we need to do, we need to have those 2 lines, and that will give us these 4 if we just leave in all the reflections. But that doesn't work because this does not go to that. This goes to here, this square here. So we need to use the reflections in the diagonals. So this, well, sorry, that will reflect down there, that will reflect down there, that will reflect there, and that will reflect there. Very awkward. So let's see if we tidy it up and we rotate the shape 90 degrees. Just 90, yes, just 90, and another 90 to 70, and then right back to where we started. Perfect. So I've never seen this question asked, but if they need to have order 4 rotational symmetry, you need to reflect in the horizontals, the verticals, and the diagonals, or just use your intuition. Best of luck.